Okay, today's lesson, we're doing investigation 8, and our topic is scatterplots. What's our objective, class? Get ready?
Scatterplots.
Scatterplots. So scatterplots are where we take some data, we put points on a graph, and then we analyze, do the points make some type of a shape that could help us identify a relationship or a trend among the points? Are all the points forming a linear trend? Are they going uphill? Are they going downhill? Is it increasing? Is it decreasing? So let's take Mr. Lopez's class. He's a PE teacher. And one student ran 3 laps, it took him 9 minutes. Another student took 4 laps, which took 8 minutes. 2 laps took 3 minutes. They're not in order. It's just a bunch of data. And then he plotted them on a graph. Notice how the graph is labeled. I have to shrink it down. I hope you can read that. This is number of laps, so 2 laps, 4 laps, 6 laps. This one is how many minutes it took to run those laps. So this dot represents one student who ran 2 laps. It took them 3 minutes. This student ran 2 laps. It took them 4 minutes. So see how to read that data? The question is, are the points, is there a relationship or a trend? In other words, could I say the more laps I run takes more time in a consistent or constant rate? Okay? As this increases, am I increasing at the same rate? Over, up, am I climbing at a consistent rate? So what we do to analyze that is we make a line of best fit. What is it called? Get ready?
Line of best fit.
A line of best fit. Well, first, I guess we have to decide, is it linear? It looks pretty linear to me. Looks like they follow this kind of an increasing line shape. So what I do is a little bit of guesswork, but you try to guess where you could draw a line where you have an equal number of points below it as above it. And not a line like this where I go, okay, I got 5 above and 5 below. That wouldn't make sense, right? Okay. I had kids trying to do this. I'm like, no, that doesn't make sense. The points go up, they increase. And so you want your line to also increase. I would also say in this case, if I ran 0 laps, that it took 0 minutes. So I'm pretty sure my line better go through the origin, just in this case. So I'm going to guess about here, and then I'm going to check. I've got 1, 2, 3, 4, 5 below, 1, 2, 3, 4 above, and so I think I kind of hit it. Luckily, I hit it pretty good. But you may not the first time. You might try it, a little bit down lower, and then count. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Okay, it's too low, so let me try that again. Okay, I think we're going to stick with that. So once I know my line, if you can, identify 2 points on the line. So all you need is 2 points, then you can find the slope. This one represents 2 laps, which took 4 minutes. This point represents, can you guys tell? 5 and 11, I think. Can I find the rate of laps, or minutes per lap now? The change in y, change in x, slope, which would be 11 minus 4 over 5 minus 2, or 7/3. I can now write that as an equation. Y equals slope 7/3 x plus, oh, I need an intercept. What's my y-intercept? Jasmine?
0.
It's where the line crosses the y-axis, it goes to the origin. And just in this case, it doesn't always go through the origin. So, we took a scatter plot. We found a line of best fit, which also can be called trend line. What is it also called? Get ready?
Trend line.
Trend line. I saw that on the RISE test last year. They called it a trend line. And I was like, oh, I hope the kids know that it's the same as the line of best fit, because Saxon calls it the line of best fit. Same thing. So there's different shapes. We did all that. So if you see a positive slope, meaning as it goes up, over, as one increases, the other increases, we call it positive correlation. What is it called? Get ready?
Positive correlation.
Positive correlation. Did you remember the question on the test yesterday? It said, the more schooling that I have, the more money I will earn in my job. Did you see that question? So if I have twice as much, so maybe I'm here, if I had twice as much schooling, will I have twice as much money? That's what that question was asking. So I would pick a dot, and I'd say, okay, so this one's got 3 years. Is there a 6th year somewhere? Okay, let's do that. This was kind of the question. Look at the 3 and the 6. If I had 3 years of schooling, and I got $2.50, and I had 6 years of schooling, is there a doubling? Is that a relationship right there? Is this a pretty constant relationship? So as this increases, does this increase at a constant rate? Yeah. What would not be is if it starts to curve like this. That's not a linear or constant relationship. I think another question said is, does this scatter plot show a linear relationship? Is it the shape of a line? Yes. Okay, as one increases, the other increases at a constant rate. If it goes downhill, it's called negative correlation. What is it called? Get ready?
Negative correlation.
Negative correlation. Remember, if my line was sloping downward, my car was driving left to right, and it goes downhill, it would have a negative slope. So it works with negative correlation as well. What if the dots are scattered randomly? There isn't really a correlation, is there? So we call that zero correlation. What is it called? Get ready?
Zero correlation.
Zero correlation. Good. So there's no line, no linear relationship. Okay, so there's your 3 choices. So I pulled this up off the internet because this is that question that was on the Rice practice test yesterday, or something like this. It said if you had 10 years of schooling, your average income could be $20,000. If you had 12 years of schooling, you might make $27,000. It's kind of like, can you guys read it from there? 14 years of education, $33,000, 16 years. So the question is, if I graph these, is there a relationship? So the graph's already been done for you. It looks like 10 years, there's your dollar amount. 12 years, there's your dollar amount. So I see a relationship. I can predict if I had 22 years of schooling, I ought to be somewhere in here because I could draw that line of best fit. And I could then figure out my rate of dollars per schooling, and I could find out where. Okay. Now, is my y-axis keep going right here? So could this line really just keep, and I could find out where my y-axis is? So basically, if I had 0 years of schooling, I'd lose money. I'd make like negative money. Anyway, so that's what we can use to do a line of best fit. I could pick 2 points. I could make an equation finding my slope. So that's what you're going to do on your investigation. Your assignment is in groups of 2 to 4. You're going to do problems 8 and 9 on this page and answer every question about the graphs. You can analyze it, explain it, and represent whatever those questions are. You know, what's the best for the x-axis and y-axis? I will ask you this. One of the questions says you're exercising, and they check your heart rate. Okay? If you're not exercising, are you dead? No. So wait, you still have a heart rate even when you're not exercising? Yeah. What's that called?
Resting heart rate.
Resting heart rate. Okay, so on your graph, don't start your graph at 90 because you should have a lower heart rate if you're not exercising. So just I want you to keep that in mind. Why don't as a class we decide that we maybe 60? What do you think? Resting heart rate's probably around 60. Okay. What if we started our graph around 60 and we go 70, 80, 90, 100, and 110? Please make sure your graphs have very carefully spaced intervals, because if you're drawing a line and you didn't space these carefully, your line won't be accurate, right? It'll go through a number that won't really make sense. If you choose to work alone, you may. Go.